Hey, welcome back, everybody. Jeff Frick here with theCUBE. We're at the Innovation in Motion Mapping and Navigation event. It's a cool little event here in Milpitas, hosted by Western Digital, and we're talking about levels of mapping granularity that I never even knew existed, even just in the application for autonomous vehicles. It's been a fascinating conversation, a lot of panels, mainly panels, a couple keynotes, but we're really excited to have Andy Parsons. He's the CEO of Increment P North America. Welcome, Andy.
Thank you.
So you were in a cool panel really talking about this debate between maps versus sensors. You know, is it the historic thing in a map that the autonomous vehicle more depends on than sensors that tell it where it is now, or the other way around? And nobody in the panel wanted to really commit one way or the other.
Well, they're not mutually exclusive.
Right.
You know, I mean, in order to make an HD map, or what we call dynamic maps in Japan, you need sensors to be able to build those maps and to build that 3D vision of the world that the car needs. So it's as I was saying on the panel, a map is historical information about what's supposed to be there, and sensors are telling you what's there right now.
Right,
And hopefully you can correlate them and everything works perfectly. But sometimes you'll see differences between what the sensors see versus what the car thought should be there, and that needs to be resolved by some intelligent algorithm.
So let's dig down into the vocabulary a little bit, because you made a very specific reference to an HD map. So what exactly does that mean?
Well, I think most of us think of a map as kind of a 2D representation of streets and features on the surface of the Earth. Excuse me. But an HD map is really something way beyond that. It's really, if you can think of it, as more like what we see when we're looking at the world. When we're driving around, we're seeing features on the road. We're seeing curbs, we're seeing lane markings, we're seeing trees and foliage, and other kinds of landmarks that are nearby. An HD map is all of that. It's knowing where you're going, but also seeing what's around you as far as the kinds of objects that we take for granted that a human can avoid or pay attention to while you're driving. A map typically doesn't include that, but an HD map, again, what we call a dynamic map, because I think it's a bit more specific about what's going on. It's all the things that are going on around the car when you're driving it, or when the car's driving you.
So dynamic by implication means moving, right? Changing within real time.
Right. I mean, a map to a certain extent is somewhat static. You know, you've got roads that don't change. I mean, they're there, and they're not going to just suddenly move to the left or something like that. Although lane markings can move. That's kind of a semi-dynamic thing that can change over time. Potholes can form. Those are things that can change over time. But you also get to a more extreme version of dynamic when you talk about things like weather and traffic. So for a car to get from point A to point B, it needs to have a plan or a route, right? So the map can do that for you. You can say, okay, this is the best way right now to get from point A to point B, taking into account all of these elements like weather, traffic, construction projects, quality of the road, toll roads. A lot of people don't think about that, but maybe you don't want to pay a toll. Maybe you want to bypass them.
Right.
So all of those things need to be taken into account when you're planning your route. And that's what an HD map does for you. And even things like if you're talking about a vehicle that is a high-profile vehicle, then maybe you want to be very careful about not being able to go, or not going in a place where that might have some difficulty getting through, like a low overpass or foliage that's growing into the street. So there's a lot of elements that have to be taken into account with an HD map or a dynamic map.
And I would imagine it even then goes to the things that we can't see with our human eye, like is there bandwidth, is there connectivity to feed the systems, are there other things going on, is it you know, in a restricted zone or whatever that feeds that map as well?
Right. I mean, there are unexpected things that are always happening on the road, as we all know. When you're driving around, things happen like maybe a kid's chasing a ball into the street. There's no way a map can know about that, obviously, right? So you need to be able to react to that and do it safely.
So it was an interesting question came out of the panel when you were on the panel. Somebody asked, can you describe what is everything going to look like in 10 to 20 years? I don't know if it was you or one of the other panelists that said no. And anyone who tells you they can, you know, they're talking science fiction. But I thought, you know, you very quickly, though, segued into a conversation about what's happening in Tokyo for the 2020 Olympics. And I thought it was interesting because it shows that the evolution into this space is not going to be smooth. It's going to be lumpy and partially driven by specific activities or specific events or specific things that will move the ball forward a certain amount. So I wonder if you can kind of share with the audience what's happening in Tokyo for 2020 around autonomous vehicles.
Sure. The Japanese government in Japan has effectively defined the Tokyo Olympics as kind of a milestone where we need to be able to have what we call level 3 autonomous vehicles up and running in the areas immediately surrounding the Olympics. So the objective is to be able to get cars that are able to navigate and get around properly by the time the 2020 Olympics happen in Japan. In order to do that, they've formed a coalition of companies where Japanese automotive OEMs, the car manufacturers, as well as the map producers, map providers like my company, Increment P. And we're basically trying to work together to figure out a way to make this an ecosystem, if you will, for high definition mapping and navigation, such that it will work in Japan by anybody who wants to use it.
Right.
It's like coming up with a standard, if you will, for
right.
use in Japan. So it's a very ambitious goal to do that in only 3 years. It's actually been
2.5, I hate to tell you.
Well, it's been an ongoing effort. For a while, it was formed last year.
Right,
this
right,
company,
right.
But everybody has a seat at the table, and we're all doing the best we can to try to make it all come together in time for the Olympics.
Right. So I'm just curious. You talked about everybody coming to the table, often competitors, trying to make this thing work. We got a unified goal. But I'm just curious to get your take on how the world is changing in terms of standards. We see in the traditional software space, open source has become a very big thing and drives a lot of what formerly would be maybe managed by some type of a standards body. And standards bodies are less important kind of in establishing these things. What's been the experience as the move towards full autonomy over time and trying to define some of these communication standards, especially as you mentioned, you want to share different types of data for the benefit of all. Is it going to be government regulated? Is it going to be, we're coming together around a particular project? How do you see that kind of shaken out?
Well, it's it's like pretty much any other standard, if you will. It's oftentimes comprised of the input from a variety of private organizations, private companies that agree to get together and make a contribution for what ultimately becomes a standard. The trick is how you can do that in such a way that you can still manage to run your business at the same time. So standards are great, but if you give everything away, then you don't have a business anymore. So it's really the challenge is how do you make a contribution to a standard and yet at the same time allow your company to differentiate itself and be able to provide solutions in the commercial marketplace. So this is always difficult. I mean, if you go back to the world I came from, which is the home entertainment industry, for example, like DVD and Blu-ray, there are a lot of companies that made contributions to those standards, and they all have competing visions of what should happen, and
right.
So we're all trying to make these contributions in such a way that you ultimately end up with something that everybody can look at and say, I'm going to build to that spec.
Right.
So it's something that's always going to be a challenge when you're talking about trying to standardize something. But I think in Japan it's unique in the sense that there's some government guidance that's happening to help encourage the companies that are all doing this on a commercial basis to try to come together as best they can to put together a coherent solution.
Right. And I apologize, I didn't give you an opportunity to tell us about what is Increment P. I've never heard it before. I'm sure there's a lot of people that
right.
Like to know more.
Well, Increment P is a company that's been around for more than 20 years. And what we do and what we have been doing is building up a very rich database of the country of Japan for mapping purposes. And, again, a map, a lot of people think of as a two-dimensional thing, but even in what we call normal or standard definition maps, there's many layers to that. So you've got terrain, you've got road networks, you've got points of interest, and many other things like railways and public transportation. All of those are different layers that sort of build on top of them. So we built up this very rich database of the country of Japan, and we license that technology to a number of other companies that use it. It could be for in-car navigation, it could be for a map application on your smartphone. And then we are continually maintaining that because in Japan in particular, the quality has to be very high. Most of the time when you're using a map, you want it to make sure it takes you where it's supposed to take you. If it sends you to the wrong place,
Usually a good thing.
If it sends you to the wrong place, your confidence level in that map goes way down,
right,
at least for a while.
Right.
So it's got to be high quality. So we also put a huge amount of energy into making sure that the quality is as high as we can possibly make it. And that's a pretty labor-intensive and fairly difficult proposition to do, and that's something that's kind of our specialty.
Right. So I'm just curious then, too, to get your point of view, which has come up again in the sessions in terms of using third-party data, whether that's community, users, maybe an independent, different government data set. How do you balance, kind of the value of getting that much more contribution into your system versus, your maniacal focus on accuracy. And how has that kind of been working out and evolving over time?
Well, there are many, many data sources we have to use. We of course, have our own data that we collect through our own survey vehicles that are literally 365 days a year driving around all the roads in Japan to get updated information. But we also get data from other sources, like, for example, traffic is provided by a single provider in Japan. That is something that we license ourselves and then sub-license to other people. So, and then points of interest. Those are things that we maintain, but we also can get those sources from other places as well.
Right.
So it's really trying to put all that together into one single category of products that are useful and dependable.
Right.
Again, nobody wants an inaccurate map.
Right, right. Well, and then before I let you go, I'm just curious, obviously maps are important to get us from point A to point B, but as you license, this data, I wonder if you can share any kind of interesting or surprising or unexpected stories of people using your data for a specific application that we may have never, ever thought of.
I think it really just comes down to, in our business, as I've said many times, we're focused on making accuracy kind of our top priority. We do have a mechanism to get people to report to us when they think there's an error. And this is the other thing, that when you talk about crowdsourcing, sometimes people will tell you something that's wrong. They'll say, you made a mistake, this is not correct. Then when you go verify it, it turns out that actually it's not incorrect. It is correct, and that person was making a mistake. So one of the challenges you have is, how do you do verification on reports that are coming back to you, or you could say it's a kind of an early form of crowdsourcing when people are reporting errors. You need to make sure that the accuracy is paramount. So, it's interesting. Sometimes you'll think that you've got some, dire problem, and it turns out that it isn't.
Right,
once you go out and verify it and confirm it, and that's a fairly labor-intensive process, and humans still have to be very involved with that.
Right. All right, Andy. Well, we're going to leave it at that, and I want to wish you well in 2.5 years and counting. We'll be watching Tokyo in
Thank you very much.
2020. Thanks again for stopping by.
All
right, he's Andy Parsons. I'm Jeff Frick. You're watching theCUBE. We're at the Auto Tech Council Innovation in Motion Mapping and Navigation Conference here at Western Digital. Thanks for watching. We'll see you next time.